So let's start our session. So basically, agenda of this program is to solve all those questions in the Striver SD sheet, right? So let's start from the beginning. If you want to solve any questions, or like if you face any difficulty in solving any kind of questions, so I will be going through and solve all those questions present in the Striver SD sheet. So let's start from the beginning, and I will guide you through each and every step how to solve each and every question. And every particular time I will be going through how we can optimize in a solution, and how we can optimize it, and what would be the time complexity of that. So all those things will be covered in this video, so you don't have to worry. You just need to go through the video very carefully, and after that you can solve you can solve that question and achieve the solution very clearly. So just go through the video, right? So let's start from the beginning. We are as the currently is day 1, and we are starting with the first day. So let's start with the matrix 0, as this is the first question of the Stavros D sheet. So let's begin and move on to solve this question. So as you can see, the question is like, you are given a matrix of dimension n cross m. Your task is to make all the element of row I and column j equal to 0. If any element in the ith row or jth row of the matrix is 0, the number of rows should be at least 1. The number of columns should be at least 1. For example, refer to the below illustration, and what you can see is this is example. Okay, let me go through the example also, and we will be covering it. First, let's understand the question more clearly. So a question is saying that you are given a matrix n cross m. Your task is to make all the element of row and j equal to 0. So what it is saying, like, we need to make all those elements equal to 0. Okay. If any element of uh, in the ith row or jth column of the matrix is 0, right? So let me understand the problem statement. So you can see here it is 2 4 3 1 0 0, right? So let's start with the sketch. Yeah. So let's say we have an example 2 4 3 1 0 0, right? So if you see that, what we need to do is, like, we need to make all those elements 0 whose ith row or jth column is having 0, right? So let's say, suppose ki this column is having 0, so we need to make this element is also 0, right? And in this case, this column is also 0. This column is also 0, so we need to make the particular element also 0, right? But here you can see all these elements are 1, whether all these elements are non-zero, and this element is non-zero, right? So we don't need to touch 2, but here it is 1, so we need to make uh, this one also 0, right? So clearly, if you go through any ith or jth column currently traversing in that matrix, if you find that this element, that particular element, any row or column has 0, then you can say that you need to make this element also 0. So let me start from the brute force way, like how we'll be thinking the particular solution to how to achieve the to a correct solution. So let's move from the brute force. So what you would think, like, when you see this question, right? So the brute force approach is like, I would be traversing in the whole matrix, and whenever I get any non-zero element, I will be traversing in that particular ith row. I will be traversing in that particular jth column, and I will be checking that if there is any 0 or not. If there is 0, then just update that particular element, right? But there one more thing you need to take care of is like you need to make a separate array for that. Why need you need to make a separate array? Because if you update in that particular matrix, what would happen is like you are not able to keep track of next element. Like how would that element be assuming that the previous element is 0 or non-zero, right? If it is already updated. So what we can say is like let's traverse in this array. So let's think like it's a very brute approach, like, but it's like a working approach. Sorry for the diagram, but yeah. Okay, don't see this thing. Pencil, where we can have the color of pencil, right? Let's see. Yeah, this is working. So what we can say like let's see, we are traversing here, right? We see that two, for that particular element 2 I will be searching here, I will be searching here, so there is no, so I will just be putting this element 2. After that I will be moving to 4, and I will be searching on its left, on its right. So I will be brute force traversing, right? So I'll be traversing on all those elements. Like so if I will get any 0, then I will just updating this element to 0, right? If it is 3, then again, so I will get 0, right? Again from this. For 1, I will be traversing. I will get again 0. For 0, you just need to don't need to traverse. You will just maintain 0. So what would the brute force approach like? What would the time complexity of this approach? So the time complexity is like if you say, so how you get to know the correct time complexity of any particular solution. So I will be like justifying that also. So let's create a new page, and let's suppose these element are all element are non-zero. So I will be telling you like how you can think of a time complexity, right, of any particular solution. So what would happen is let's say this is a 2, right? So for that particular element you will be traversing on each for that particular whole index, whole row, and for particular column, right? So you are suppose the row size is like row is n, and number of rows is n, and number of columns are m, right? So in that case you will be traversing n elements, n minus 1 element here, and m minus 1 element here, right? And this you are doing for each and every case. And how many elements are there? Overall there are n into m element. So what you're doing is like the time complexity will be n plus m minus 2 into n into m, right? So what do you think of approach, like which very good approach or very bad approach? It's not good, right? You are taking a lot of time. So suppose if n is 10 to the power 5, then your time complexity like 10 to the power 3 also, then also you are be like 10 to the power 3 here, and 10 to the power 3, 10 to the power 9, you will be reaching toward 10 to the power 9, right? So time complexity is very bad. So you need to optimize this solution, right? So do we need to code this solution? I don't think we need to code, right? And Okay. So let's think like element can be anything, right? 10 to the power 9 to till but the size is 10 square. So what you are saying that if it is 10 square, then it will work, right? Because 10 power 2 into 10 power 2 into 10 power 2, 10 power 10 power 6 only. So and then this approach will work, right? But if I want to optimize, so can you think of any optimization, right? Like optimization would be anything, right? Suppose you are thinking that let's take a different kind of input and think of it, right? This is 0, right? And 0. So for this particular 3, you will be traversing the whole, you need to traverse, right? You will be traversing here. But whenever you get a 0, you just say that this is mark, right? You mark that element as 0. So do you need, yeah, I also don't talk about that space complexity, but you have need to create a big of n into m space also, right? But so what can you do? Any optimization if you can think of, can you just tell me no? Like you can think it for a 2 minute, like you can just pause the video and think for a 2 minute. Okay, so now you have think, so I will be giving you a particular solution, right? So if you think in that manner, like what we need to take care of, I just need to take care of 0, right? If in that particular row 0 is there or not. If 0 is there, and I need to make all those elements as 0, right? So here I need to make this element 0, this element 0, all these elements 0, right? I don't need to think of any other. So if similarly for the column, suppose if I maintain a single n size row, m size row, m size a vector, or you can say any array. In that I will be checking like if any particular element is 0 or not, or like you can just think it of as like you will check any particular index and you will say that there is 0 or not. If it is 0, then for that particular I, you need to have element as 0. So here I is 0, j is 1. So you can have two vectors, one vector is for row and another vector is for column. So you can store it like for the 0th row I need to have, for the 1th column I need to have. Again for this one you can store 2th row, 0th column. By this, what you can say, what would the time complexity? You are traversing in a whole array and you are making storing this in a vector, right? And again you are traversing here also. But I don't need to do this kind of solution. How would I think of another better solution, right? So this will again lead to same, right? If you are marking this to, because you need to traverse it two times. So 2 into n cross m, it is like something like that kind of solution. Why I'm saying n cross m is like firstly you will traverse and like mark all those, right? And after that you will be traversing at, in worst case you will be traversing again n plus m number of rows are there. So same solution will be there, n plus m into n into m. So the solution time will not be gonna change, right? So how good can I optimize the solution? Let us think, I like what would be a more possible optimal solution if you can think of. Any solutions? If you can't think, then like again we need to just like this solution is not a like optimal solution, but you think, right? You have thought like we can also move, we can also think like that, but there is some hack, there is some optimization still you can think of. So and why I'm giving this kind of approach, like you can basically improve each and every time when you think like that, right? Okay, so uh, now what can you do is like you can take an like any optimization, guys, if you can think of. I'm also thinking like because I have not solved any of the question, but I am currently thinking, right? What we can do is like let's think of it. Okay, so let's like what we can have, right? So let's say कि we can have a vector, like again I'm saying that this solution which I'm thinking of it is a kind of correct solution. So what we can do, we can have an array of column size and row size, right? And why we are having this array is like let's think of it, right? Why I'm having this array. So firstly suppose this is 0, right? So this is talking about the column, so I will be updating here like I'm getting this 0, I'll marking 1 here, I'm marking 1 here, I'm marking 1 here. So what this is suggesting that I need to make all those elements in that particular column as 0, right? Here same, right? If you get any element in this row, mark 1. mark 1. And after that, what you need to do is like just need to update. So what would be the time complexity of this solution? The solution time complexity will remain same, I think. It will not remain same, but it just will be a little bit change, right? Firstly, you will be traversing a hole for updating this, right, and cross m. Next, you will be traversing again this many times. So in worst case, you are traversing n cross m elements twice, right? Why twice? In the whole row you are traversing and making element 0. In whole row you are making the element 0. So in column, what you need to do is like if you say that the first element is 0, then don't do anything. If the second element is like, you are traversing two time, right? So that would be enough. You don't need to move further. Any optimization you can think of. Like this would be a solution of big of 2 into n cross m and space complexity a big of n, big of n, max of big of n comma m, right? But can you reduce this space complexities to big of 1? Is there any way you can think of? This solution will work, my dear, but can you optimize the solution, right? Like how you can reduce the space complexity. The time complexity is better, like 2 cross n cross m will be like a fine time complexity. If you write this code, then what you can say is this is a simple code, right? So what I told is like let's create a row and where we can have, you can say, we can have column. If matrix of ij is 0, then you just make that particular row of I is equal to 1 and column of j is equal to 1, right? And after that you just need to traverse then that particular matrix, and if you find that this particular row of I is equal to 1 or column of j is equal to 1, anyone, then you just make that particular matrix of ij is equal to 0 and you return the matrix. Right, but this code I have written in Java, so let's change the language to C++. Again try to run the code. So yeah, it's working fine, and let's try to submit the code. So yeah, it's worked. But do you think this is the optimal solution, guys? Because optimal solution is something uh, uh, like I have taken these two rows and column, right? Can I think of some much more optimal solution than that? Because in interview you don't need like you if you say there's an easy problem you can just come up with the one solution that the brute force solution, then that would be not be enough in an interview, right? You need to come up with an optimal solution. So what better you can do, guys? Do you need to have this rows and column? If you can think to eliminate this rows and column, then how you can eliminate this rows and column? Any approach?